Again, now we come to the next video where I'm going to discuss the curl of a vector and solenoidal vector. But what is meant by solenoidal vector? If you have v bar is a scalar point function or a scalar function, then this vector v bar is called a solenoidal vector if divergence of this vector is equal to 0, that is del dot v bar is equal to 0. So remember that what is meant by solenoidal means if a vector, it means that if the divergence of any vector given any vector scale vector field function, if its divergence is equal to 0, that is if del dot v bar is equal to 0, then such a vector is called a solenoidal vector. Now one such example is that show that a constant vector is solenoidal. So any constant vector is always solenoidal. You have let v bar be a constant vector. Now what we have to show is that to show that del dot v bar is equal to 0. So we have now divergence of v bar, which is equal to del dot v bar, this is del dot v bar, is equal to I del x plus j del y plus, there is no dot here, plus k del z dot of vector v bar, where vector v bar here is a scalar, is a constant vector. So what we have here is, according to definition, it should be, according to definition of divergence, it is I dot del v bar del x plus j dot del v bar del y plus k dot del v bar del z. But we know since v bar is a constant vector, so if you differentiate a constant vector with respect to x partially also, it will give you 0. I into 0 plus j, the partial derivatives of constant vector with respect to x, with respect to y, or with respect to z will always be equal to 0. So you have here k dot 0, which is equal to 0, because I dot I here, you can express this as a 0 vector, so this as a 0, so I dot I here will give you 0, so this whole thing will become a 0 quantity, 0 scalar. Okay, so this shows that, so this, since you can say that since del dot v bar is equal to 0, it implies that v bar here, which is a constant vector, is solenoidal vector, is a solenoidal vector. I hope it is clear what is meant by solenoidal vector. Now again with this same, if v bar is a constant vector, irrotational vector, a vector v bar is called irrotational if curl of v bar is equal to 0 vector. So if you have curl of vector v bar is called 0, such a vector is called an irrotational vector, that is del cross v bar is equal to 0 vector. So by curl of v bar, here we have, this is I del, that is del cross v bar is equal to I cross, I'll just write del v bar del x plus j cross del v bar del y plus k cross del v bar del z. So but since this vector v bar is a constant vector, so you differentiate it with respect to x, it will give you 0. So I cross 0 plus j cross 0, here you will get a vector only, plus k cross 0, so which is equal to a 0 vector. Okay, so therefore here again, here it should be 0 vector. Okay, because the scalar product of any vector will always be a scalar quantity, whereas here it is the cross product, which is a vector quantity. So you have here this curl del cross of v bar is equal to I cross del v bar del x plus j cross del v bar del y plus k cross del v bar del z. But what is v bar here? It is a constant, I'm taking here constant vector. So if you have v bar is a constant vector, then such a vector is an irrotational, because the gradient, the curl of this vector will always be equal to 0. So any constant vector is always an irrotational vector, and also at the same time it is a solenoidal vector. Why? Because the divergence of this constant vector always give you zero quantity. Next we come to this problem on curl of a vector function. If you have r bar is equal to xi plus yj plus zk cap, then find curl of r bar. So curl of r bar is equal to del cross r bar, so which is equal to, according to definition, it is I cross del v bar del x plus j cross del v bar del y plus k cross del v bar del z. But at the same time also you can express curl in the form of determinant. That is where you have to write this is determinant, where the first row should be ijk, second row should be the coefficient of this ijk of this vector operator del, that is del x, the coefficient of I here, coefficient of j here it is del y, coefficient of k it is del z, whereas the third row should be the coefficient of ijk of this vector v bar, that is v1, v2, v3. Remember that never express this determinant rule where v1, v2 you express it in second row. That is the wrong method, okay? It is not correct. Always remember that the first row it should be ijk, the second row should be the coefficient of ijk of this operator del, which is, what is this operator del? That is this, that is coefficient of I is del x, coefficient of g is del y, coefficient of k here it is del z. Now as you can see, the third row will be the coefficient of I here, that is v1, put it here, coefficient of g of this vector it is v2, coefficient of k cap is v3. So now use determinant rule, it gives you I into del v3 del y minus del v2 del z plus j into del v1 del z minus del v3 del x plus k cap into del v2 del x minus del v1 del v3 del x minus del v1 del v2, I mean this is del v2 minus del v1 del y. So using determinant rule, now I can express this curl here is I j k, where the second row should be the coefficient of ijk of operator del, that is del x, del y, del z. Now what is the coefficient of r bar, vector r bar? It is x here, it is y here, it is z. Now use determinant rule here. What we have is I into, where you eliminate the first row and the second, the first column. So I into del z del y minus del y del z, and then plus j cap, where you eliminate the first row and the second column now. So you have here del z, because I'm putting here plus, so first cross multiply from here, del z, not from here to here. First you take this term, so you have del x del z minus del z del x, and then plus k cap, eliminate this and the third column. So you have del y del x minus del x del y. But differentiation of z with respect to y will always be equal 0. So therefore this is equal to I into 0 plus j into 0 plus k into 0, so which is equal to a 0 vector. So therefore curl, if r bar is equal to xi plus yj plus zk, then curl of a vector r bar here is equal to 0 vector. So if it is a 0 vector, by irrotational vector we mean that if the del cross v bar is called 0 vector, it means that v bar here is an irrotational vector. So since you have r bar is equal to this xi plus yj plus zk, and you find the curl of this vector, that is del cross r bar, which gives you 0 here. So this shows that vector r bar, this implies that vector r bar which is equal to xi plus yj plus zk cap is an irrotational vector, because the curl of that vector gives you a 0 vector. I hope it is clear to you.